Our notes today are going to be on piecewise functions. A piecewise function is defined by two or more equations. Each piece of this function applies to a different part of its domain. So remember that your domain is your x values, and this is an example. So the way that we show a piecewise function, we give it a name. Okay, f of x. F of x is going to be overall as our output. Our input is still x. Then they use these braces often to show that we have two different pieces to this function. So if x is less than or equal to 0, so that is if our input is less than or equal to 0, we are going to be evaluating x minus 2. And if x is greater than 0, if x is positive, we're going to be evaluating 2x plus 1. So what we want to think about is that when x is 0 or negative, this is going to be the function f of x equals x minus 2. Okay, and so this is a line. Hopefully you recognize that it has a slope of 1 and a y-intercept of negative 2. So here's our slope of our y-intercept of negative 2, and we can see that this function has a slope of 1. Rise 1, run 1, okay, up 1, right 1, or equivalently down 1, left 1 would be negative 1 over negative 1, which would also give us a slope of 1. And you'll notice this piece of the graph, this f of x equals x minus 2, is only graphed for when x is less than or equal to 0. Okay, and then our second piece of the graph for when x is positive, right? So here's where x is 0. So here's where the graph sort of starts, is also this linear piece. F of x equals 2x plus 1, so y equals 2x plus 1. So this has a y-intercept of 1 and a slope of 2. And you can see that y-intercept of 1 here, and the slope up 2 over 1, up 2 over 1. So there's that slope. Okay, so a couple of things you might have noticed hopefully here is notice that here we have a closed circle. Okay, you should remember that a closed circle from your inequalities means that it's included in the solution, right? And so if you look at the inequality here of the piecewise function, that less than or equal to 0, when x is equal to 0, right, we are using this function to evaluate. So that's why we have a closed circle. Now if you look at the other piece, you'll notice that it has an open circle at the end. As you remember from rational functions or from graphing our inequalities, when we have an open circle, that means that point is not included. Okay, and that makes sense because here our inequality is we're only looking for when x is greater than 0. So right beyond x is 0, right just a little bit positive, right, we do want to include that, but right at x equals 0, we evaluate, but we put an open circle there because that is not included in the graph. Okay, and so also if you notice here, this is sometimes a little strange to people, but we actually, our domain is all real numbers, right? Because we have this first piece evaluated for negative infinity up to and including 0, and we have this second piece for when x is greater than 0. Okay, so every x value has a point that corresponds to it on our function. And our range can be different for everyone, but here we can see we start at negative infinity down here, we go up to negative 2, and it actually includes negative 2. And then if we start our next piece, it does not include 1, and it goes up to infinity. And I realize what I said might have been a little misleading. The domain of every piecewise function is not negative infinity to infinity. You have to look at the individual functions, but in this specific case, okay, we have a function that's defined for all real numbers x. So that's sort of a beginning picture of the graph. So next, we're asked to evaluate the function. So here we actually have two piecewise functions. We have the piecewise function f of x, which has two pieces, and we have the function g of x, which actually has three pieces. So what you're going to do when you're evaluating these is first you're going to look for the function name. So this tells us we're looking for f of 0. So looking at f of 0, between my choices f of x or g of x, I'm going to choose f of x. And then I'm going to look at my input of 0. And so we want to look at the two branches. The first branch is for x less than or equal to 1. Okay, and since 0 is less than or equal to 1, we're going to look at this first branch. So for f of 0, we're going to evaluate 3x minus 1. So this will be 3 times 0 minus 1. Okay, or that evaluates to negative 1. For f of 1, okay, we're going to look, and again we're going to evaluate f because that's the name of the function, and we want to think which of these branches holds when x is 1. Okay, and so we can see this branch is for when x is less than or equal to 1, right? And since 1 is less than or equal to 1, again we're going to use that first branch. So this is going to be 3 times our input value of 1 minus 1, 3 minus 1, this value would be 2. For our third one, again, we're still looking at our function f. We're looking at the input 5. So since 5 is greater than 1, we're going to look at our second branch. So this is going to become 1 minus 2 times 5. So 1 minus 10 is negative 9. Now our next one, f of negative 4. So again, negative 4 is less than or equal to 1. So we're looking to evaluate the first branch. So 3 times negative 4 minus 1, negative 12 minus 1 would be negative 13. Okay, and for our next one, now we're looking at function g. Okay, and function g has three branches. So if I look at 0, I want to see which inequality 0 makes true. So 0 is between negative 3 and 1, so I'm evaluating in my second branch. And that tells me that for every value between negative 3 and 1, my g of x value is going to be 2. My next one, I'm looking at negative 3. So I can see that negative 3 is less than or equal to negative 3, so I'm choosing my first branch. So 3 times negative 3 minus 1, that would give me negative 10. So pause the video at this time and try the last three on your own. So for g of 1, 1 satisfies the inequality, 1 is greater than or equal to 1, so this would be negative 3 times 1 is negative 3. 3 satisfies the equality, 3 is greater than or equal to 1, so this would be negative 3 times 3, which would be negative 9. And for 9, we're looking at negative 5. Negative 5 satisfies the equality. Negative 5 is less than or equal to negative 3. So this would become 3 times negative 5 minus 1. Negative 15 minus 1 is negative 16. So I think it's probably also worth saying right now, this would correspond to the point 0 is our x, negative 1 is our y. Similarly, 1 is our x and 2 is our y. If we move down to our g function, okay, these would be the same for all of them, but this would be the point 0, 2, input, output. This would be negative 3, negative 10. Okay, and you could do that for the other problems as well. So turning on to the next page, for each of these, we want to graph the function. So just real quick, draw in a grid for yourself. I actually think I'm going to pause here and start a second video. Please watch the next video.